Good day everyone, this is our Chapter 7, Fluid Flow in Pipes with subtopic in Darcy-Weishaupt formula and finding the value of F or the friction factor. So as we all know, this topic is all about finding the discharge based on the given values and solve answers from the head laws of Chapter 5 pipe using the Bernoulli equation, where our Reynolds number would become 3368.42. Remember that our discharge, or Q, would have a formula of Q is equals to area times the velocity. So before we start, let us first take a look and have a short opening for our topic. So head losses in pipe flow. Head losses in pipes may be classified into two. The major head loss, which is caused by pipe friction along the straight sections of pipe or uniform diameter and uniform roughness, and minor head loss, which are caused by the changes in velocity or directions of flow, and are commonly expressed in terms of kinetic energy. So as you can see here, this is an illustration that explains the different types of flow, where there is a Reynolds number from 1,600 to 10,500 with its different diameters. Meanwhile, on the other hand, is an illustration that explains a laminar flow. There are different ways on solving our major head losses. So we have here our Darcy-Weishaupt formula, Manning's formula, and the Williams formula. But in this topic, we have chose the Darcy-Weishaupt formula, or the HF is equals to the friction factor times the length over the diameter times the velocity squared over the 2g. Or you may also refer this information for the Moody friction factor chart in getting our F. Or you may also have these formulas instead. So orifice with constant head has different purposes, and there is other ways of solving our friction factor. But in this problem, we have used this formula in laminar flow, which is F is equal to 64 over the Reynolds number, or 64 mu over the rho dV. Let us first identify the givens in the problem. So our length would become 4,500 meter, diameter of 650 millimeter, which is converted into meter as 0.65 meters, the Z2 of 0 meters, and our Z1 elevation is 8 meters. Using the formula HF is equals to Fl over D times the V squared over 2G, we can now plug in all the values given. 11.35 meter, which, as we can recall from chapter 5, is our head loss, is equals to 0.019 times the 4,500 meter over 0.65 meter. Cancel out meters and then multiply it again by V squared over 2 times 9.81 meter per second squared. So, to get our V and solve for our discharge, we must multiply and plug in all the numbers. So, we can get the result of V is equals to 1.3023 meter per seconds. And finally, solving for our discharge, which is Q is equals to area times the velocity, which would become the area of the circle is equals to pi over 4 times the d squared and the volume. So pi over 4 times 0.65 meter squared times 1.3023 meter per seconds. So multiplying all the answers and combining all the units, the answer would become Q discharge is equals to 0.43214 cubic meter per seconds. And that would be all. Thank you for listening to this video. Thank you.